Today we are going to learn series negative clipper. Alright, negative clipper means we clip or cut the negative waveform of the cycle. Okay, before we start that, let's revise about clipper. Clipper is cut or remove either positive or negative half cycle or remove some kind of portion also. Alright, so in the waveform we can remove half of cycle or remove peak portion of the waveform. So the application of the clipper, which is mostly used in a communication way in a TV and radio. Radio means AM and FM. Alright, so in a speech signal which is convert into the waveform. Okay, so waveform is a transmission of speech signal. So in this speech signal, if we want to cut noise or we want to cut some level of the peak, so that time we use clipper. And also we use clipper as a reference amplitude and voltage. So because of that, as a reference we use, that time we select or limit our speech signal. Okay, so this is used for the clipper. This is types of the clipper: series and shunt, positive and negative, series and shunt, positive and negative with bias, and dual clipper. Alright, so let's quick revise of series positive clipper. This is called positive clipper because we cut or remove positive half cycle. Alright, so when A is positive with respect to the B, then positive and diode connect to the cathode side or negative side, so which is in reverse bias. That's why we are not getting any wave. Okay, there is no wave. But when A is negative and B is positive, so this negative and cathode which is going to in forward bias. Alright, so we get negative waveform, negative side. Alright, now we see another, which is series positive clipper with positive bias. Alright, positive bias, it means we use battery as it is, positive and negative. We are not switching the terminal, first is negative and second is positive, but here is first positive and then negative. That's why it's called positive bias. Alright, bias means we are using another source. Okay, this is the source which are connect in AC, but another source is this battery. Alright, so when A is positive and cathode is diode is in cathode connect with the A. Okay, so which is in reverse bias, but battery terminal plus connect to the anode, so this is become forward bias. As you know that in reverse bias voltage is less, but in forward bias voltage is more. Alright, so because of the difference of VI and VB, we are not getting output as input. So because of the difference we are getting output as VB but not Vmax, because this here is 0.7, so there are the difference of voltage because of this difference. Okay, so this is series positive clipper. Now we see series negative clipper. As you see in this circuit, this is the same circuit as a half wave rectifier. There is nothing different in it. Okay, and the output is also same as a half wave rectifier. Okay, so see in a negative clipper, so clip or cut the negative side. Okay, so when A is positive with respect to the B, then diode is becoming forward bias. Okay, So with positive half cycle, diode is becoming forward bias. That's why we get output. But when A is negative with respect to the B, and in negative half cycle, diode is becoming reverse bias. So we are not getting any waveform. So clip the negative side of half cycle. That's why it's called series negative clipper. Alright. Now we see series negative clipper with negative bias. Alright, as you can see here, A is positive with respect to the B. Alright, so this is anode, this is cathode. Alright, so diode is becoming a forward bias, and here is also, this is negative connection, negative terminal of battery which is connect to the cathode. Alright, that's why it's called negative bias. Alright, so this negative and this is also cathode, so this is also becoming a forward bias. So whole circuit in the forward bias, that's why we get waveform as input. Alright, but in reverse bias, let's see, A is negative with respect to the B, then this become in a reverse bias, this is in forward bias. Alright, so this side is become in a reverse bias and this side is become in a forward bias. Of course you know that reverse bias has less voltage Vi, but Vb is greater than Vi. Alright, so Vb has more voltage than Vi, so this is the voltage different. Alright, in negative half cycle, that's why because of the difference in 0.7 voltage, so we are not getting 0.7 voltage, we are getting difference one. That's why we cut the peak of the negative half cycle. Okay, this is series negative clipper, this is series negative clipper with negative bias. Now we see shunt positive clipper. So here is something different you have to remember. This is R1. If this is only one resistor and this is only one diode, then what happened? A is positive with respect to the B, then A is become forward bias. Alright, but in forward bias we have to get the wave here, but we are not getting, right? So this is positive clipper. Okay, so positive, it's going to cut, but this is forward bias, so we are get positive half cycle, but we are not getting it. So this is another resistor that we are connected here, which is R2. Okay, so let's see. In positive half cycle, when the input voltage is applied, then positive half cycle in input makes the point A is positive, okay, with respect to the B. What happened that time? Diode is becoming a forward bias. Okay, so this is going to like this, so current will flow like this, so it become in a closed circuit. Alright, but voltage across the load resistor or R2, okay, is become 0 because there is no any current will flow, because it is become in a forward bias. Okay, so current will flow like this, but there is no output comes here, there is no resistance, that's why we are not getting any output. Okay, so all current will flow like this. Alright, so this is forward bias, we are not getting any output. Alright, but in a reverse bias, let's see, this is negative and this is positive, so diode is becoming reverse bias. Okay, so there is no closed path upon here, current will flow up this path and this path, but not this path. Why? Because this is in reverse bias. But from this part and this part we get the output. Okay, so that's why we get negative half cycle. Only this path is become in a reverse bias, not whole path. Okay, so from this two wire we get the output which is negative half cycle. But in forward bias we are not getting any half cycle because this is getting in a closed path and there is no load resistance here, so there is no current comes here. Okay, so this is shunt positive clipper. This is in a shunt which is parallelly connected, that's why. Okay, let's see another shunt positive clipper with bias. Okay, so let's see. I am here also connect the resistor R1 and R2. Let's see what happened here. When A is positive with respect to the B. Okay, so when A is positive, diode is becoming forward bias. Okay, but positive bias, that's why the terminal of battery is positive, which is connect to the cathode. So this becoming reverse bias. This is forward bias and this is reverse bias. So voltage of Vi is more than Vb. Okay, so this is become a difference of this reverse bias circuit and this forward bias circuit. So voltage is different, which is this is R2 minus R1, or you can say R1 minus R2, which is same. Okay, so Vi is greater than Vb, which is less than 0.7. Okay, this is difference in current also. That's why we are not getting 0.7 V maximum. Alright, because of the difference. You can remember here is Vi greater than Vb in positive shunt clipper with positive bias. Alright, but in this circuit series positive clipper with positive bias, Vi is less than Vb. Okay, so here is reverse bias but here is forward bias. So please remember that, which is difference in voltage because of the diode in forward and reverse bias. Okay, now see in negative half cycle, A is become negative, B is become positive. Okay, now A is negative, so this is going to in reverse bias and here is also reverse bias because this is cathode and this is plus terminal, positive terminal. Okay, so this is not going to connect with whole circuit because this all is becoming a reverse bias. So our input is going direct to the output side. Alright, that's why we get the same waveform as a input. Okay, so this is shunt positive clipper with positive bias. Okay, I hope you understand the concept of this clipper. Thank you for watching.